Hello, everybody. This is your E-Day assignment for 10th, 2025. We are working on classwork 1.3. This is going to be your attendance for the day. So this is going to be due, I'm going to make it due at 11:59 p.m., I think. As long as you turn in your classwork by then, I will count you present for the day. So if this were a normal class session, there'd be a big discussion among your group. You'd talk about maybe some social media apps that you might use, and then maybe make some assumptions about what you think the class would do. Because of our circumstances, we just did an informal survey yesterday. So at the end of class, I took just a hands up. If your favorite app is TikTok, raise your hand. Instagram, raise your hand. Twitter, raise your hand. And then we didn't have anyone say anything else. So one thing you'll notice, if we take 2 plus 12 plus 1, so 2 plus 12 is 14, plus 1, that's 15. Our class had 19 people in it yesterday. So that is an issue that we would normally try to fix. We usually want to try to get actual all-encompassing data for everyone in the class, but for our purposes today, 15 is fine. We'll just keep in mind this is an incomplete data set. We also had some people absent yesterday. We had some people leaving early, so that also makes up our missing data there. So 2 for TikTok, 12 for Instagram, 1 for Twitter. What we are doing today, this is all about making good graphs with categorical data. So remember from yesterday, we learned about the 2 data types. We have numerical data, and we have categorical data. And the fancy scientific names, the numerical data, that goes with that quantitative. And the categorical data, that is qualitative. You can remember that because quantitative has an N in it. N is for numbers, right? Qualitative here. I misspelled that. There we go. Qualitative. So, yeah, as I said, quantitative has that N in it. So you remember that goes with the numerical, also a quantity. That is just a synonym for a number. So those two go together. Qualitative and categorical, those are the same thing. When we have categorical data, there are a few types of charts that we are able to make. We can make a bar chart. I'm sure you're familiar with a good bar chart. We could make a pie chart, only in some circumstances though. We'll talk about that. And we could make it's called a Pareto chart. And that might sound completely foreign to you. I promise it's not. We'll see how to do a Pareto chart later. Okay. The whole numerical thing over here, we're going to talk about some different ways going forward. We're going to spend a few days talking about numerical ways to organize data. So, bar chart, pie chart, Pareto chart, those are the goals for the day. After that, we will also do some work with time series charts. Those are more like scatter plots. We'll see how that works as we go on here. So, 2 for TikTok, 12 for Instagram, 1 for Twitter. We are actually going to make the charts first with this little website, and then we're going to talk about the good chart making procedures for you to follow when you make a chart by hand. So this is how these lessons are structured. You tinker with the ideas first, and then we're going to formalize them later. And actually, I need to wipe that because we're going to be using it. So, let's go to this StatsMedic link. All right. So once you're on this site, we're going to look at the top of this page here. This just is a bunch of different tools for displaying data, calculating different data things. It's really easy to work with, and so that's why we're going to use it today. We'll use this in the future on occasion, but for the majority of the stuff, we're going to be working with the calculator, which can do the same stuff as this website can. Just because your calculator, you can use that on your exam. You can't use this website on your exam, and so it's less useful sometimes. All right. We need one categorical variable, single group from that website. And all that's talking about is we're working with categorical data, right? We didn't answer with numbers when we answered that favorite social media question. We answered with words. So people said TikTok, people said Instagram, people said Twitter. Now we still got numbers from that. We had 2 people who said TikTok, 12 people who said Instagram, but that doesn't necessarily make it numerical or quantitative data. Just because we have counts of how many people answered categorically does not make that quantitative. So this is still qualitative data here. It's just that we have counts of that qualitative data. These are called frequencies, in fact. Frequencies. So the number of people who answer a certain way, that is the frequency. Now that we've established that, so categorical variable and single group just means we have one variable. So I asked one question, what's your favorite social media? Favorite social media in this case was our variable. And so there's no other question I asked. So it's just a single group there. So one categorical variable, single group. And then we've got a little drop down here. So in the variable name, I'm going to write down, I guess it should be favorite social media. And we had 3 different options. So we could have said TikTok, we could have said Instagram, and we could have said, what was the other one? Twitter. So we had 2 for TikTok, 12 for Instagram, and 1 for Twitter. Once we got those, I got that extra row, by the way, by clicking the little plus button in the bottom right of that table. But once we have those, go ahead and click Begin Analysis. On this screen, we've got the graph distribution. This is the bar chart, in fact. So this is your bar chart. You're going to want to copy this over. Go ahead and sketch it and notice what they do. So look at all the stuff that they have labeled on here. Make sure that your bar chart has that. To get your pie chart, you're going to click that button. And I actually want you to label with the percentages. So make sure when you click, just click each of these little wedges here, and that's going to show you the percentage for each section. So go ahead and do that on your own, and then come back and continue the video. All right, you should have your bar and pie charts copied down now. So when we look at the bar chart here, we have a couple important features to note. First, we've got 2 axes on our bar chart. We've got the up and down axis, we would call this the y-axis on a normal graph, but it's a little different with a bar chart. This is just going to be where we put the frequency. So however many people answered each way, that's what we put on the frequency. So we had 2 people who said TikTok, so they're up to 2. The big difficulty is scaling this. Say we didn't have a class of 12 or 15 people, but we had a sample of like 2,000. We wouldn't necessarily go by ones as we made that bar chart. We would probably make a decision to go by 5s or 10s or 100s, something like that. The other things that are important here. On the bar chart, we've got space between the bars. So I'm going to make a little arrow pointing to that. Space between the bars. We are going to have a chart that kind of looks like a bar chart later, but it doesn't have space between the bars. So we need to make this distinction. It's an important distinction now so that we can see what the true bar chart is. So true bar chart has space between the bars. The other important thing is that the bars are equal width. So imagine for a second that instead of having an equal width bar for Instagram, I instead just made it really small. I guess that's not going to do it. Select that. Yeah, so I just make it a little thin little bar. The whole idea of these bar charts is that your brain actually sees the area and looks at the area to compare the bars rather than the height necessarily. So even though your brain says, okay, Instagram is taller, it makes it a lot harder to see how much taller Instagram is relative to like TikTok down here, because we have basically cut the Instagram bar in half by doing that. So we need equal space for each bar. We need equal width. Mine's not perfect here, but that space between the bars should probably be equal as well in a perfect world. Another important thing, it's going to trip everyone up on this first test. We need labels. We need to label the variable on the x-axis, and we need to label that this is the frequency on the y-axis. So make your labels known, and actually you need 2 tiers of labels on a bar chart. You need to show me that this is your favorite social media answer to the variable here, so list the variable, and then you need each possible answer. You need to list out, okay, TikTok and Instagram and X and Pinterest or whatever else we might have going down the line here. Then we look at the pie chart. The pie chart starts with that circle. It's pretty classic, and then we break it up into the wedges. And the whole thing about the pie chart is it shows percentages. So bar chart shows what we would call absolute values. And the pie chart, or absolute frequencies rather, instead of values, absolute frequencies. The pie chart shows relative frequencies. And that word, relative frequency, what does that mean? Relative frequency just refers to a proportion or a percentage. So a proportion or percentage. So instead of looking at how many people answered with TikTok or Insta or X, I'm looking at the proportion of people, the percentage of people who answered with TikTok or Instagram or X. The difference here is relative frequencies are much more comparable across differently sized samples or populations. So our class is only 19 people strong. We only had 15 people answer the survey. So remember our sample size symbol, that is N in this case, is 15. We only had 15 people answer. But say we had another class and it was like a giant university class in a lecture hall. It was like 500 students. Well, that class could have a different breakdown, or it could answer more or less the same. Say instead of 12 people liking TikTok, we had 400 people liking TikTok. So if I looked and I compared our class to that college class, I would go, and I was only looking at absolute frequencies. I would go, oh, that Instagram, it only had 12 people who liked it in the Hoffman stats class, but in the college class, it had 400 people who liked it. Well, that's not exactly fair. We're trying to compare that n equals 15 to a sample size of much more people, n equals 500. So when we have these giant differences in sample sizes, that's where relative frequency comes in. That lets us compare. 400 people out of 500 is actually the same proportion. It's 80%. So we could say that more or less in that college class, the same proportion of people enjoyed Instagram, even though it's not necessarily the exact same amount. So as those sample sizes increase, we expect more and more people to answer the same way. What would be really interesting is if they answered these relative frequencies different. Maybe college students like Instagram less and like a different form of social media more, something like that. But the relative frequency allows us to do that. Relative frequency, we always say the percentage or the proportion is going to be x over n. It's just a fraction, where x is the frequency of one answer, and n is your sample size. So to find the percentage of people who like Instagram, I would just do 12 divided by 15. And if you do that in the calculator, you get 0.8. And then we need the percentage of that. So multiply by 100. And that gives us 80%. So we've got the frequency, we've got the sample size, we've got the percentage now. How do we get this into bar chart form? And this is the really difficult part of a bar chart, is if we wanted to do that by hand, the process would be very geometrically involved. We'd have to take that percentage, 0.8, or the proportion rather, 0.8, we'd have to multiply it by like 360 degrees, because that's the amount of degrees in a circle. Oh, let me do that math real quick. I messed up on my calculator. 360 times 0.8, that would be 288 degrees. And then we'd have to draw a perfect circle, and then we'd have to mark the middle, and then we'd have to get the protractor out, and we'd have to measure a perfect 288 degrees for this, or rather we'd probably have to do 360 minus 288, and that's 72. That's much more manageable. We'd make a 72 angle precisely here, and then we'd have to split that up according to these probabilities. It just wouldn't be very fun. So we are not going to make pie charts by hand in this class. We're going to see pie charts a little bit, probably not dwell on them too much, but it's just simply not worth all the effort of getting the protractors out, trying to make all those. Instead, we're going to tell a computer to do it. And so that's why we used Statlet today, that little stats applet that we used. We'll use maybe calculators in the future. It's involved to do that. I wouldn't worry about it too much. So all you need to do, use your Statlet, use the website, copy down the pie chart, just sketch out what it looks like on the computer, and that's what we'll do. We'll just call it a day from there. There's not going to be any involved test questions about making a pie chart by hand or anything like that. So just sketch your pie chart from technology, and that is completely fine for this class. All right, the last thing that they want you to do on this page, and I had a little bit of a graphical glitch here, so I apologize for that, but the last thing they want us to do is to make a bar or Pareto chart. And the nice thing about the Pareto chart is it is literally just a bar chart, but in order from least to greatest. So I'm going to erase all these notes that I made. And now we just have to organize these bars so that they go from least to greatest. So let's move this bar out of the way. Let's move this bar. Let's move that bar. The first bar that we need is going to be the X label. So I'm going to put that first. So X goes first. Then we had TikTok. And then we had Instagram. So X only had 1. TikTok only had 2. See if I can get that lined up. There we go. And Instagram had 12. So that is the Pareto chart. It's just nice because it goes nicely in order. And I'm actually going to make sure real quick that it goes from least to greatest and not greatest to least. Oh, it does go from greatest to least. So there is an error on that worksheet. My bad. So instead of least to greatest, we're actually going from greatest to least. So I'm going to have to flip this around real quick. Instagram will go first. X will go last. And there we go. So yeah, nice curve. You can see, okay, Instagram's first, TikTok's second, X is third. Really easy to see, really easy to just glance at and gain your data from it. It's just another way, a Pareto chart, another way to organize that bar chart. All right, looks like I accidentally wiped my quick notes when I did that earlier. So I'm just gonna pull up the quick notes from last semester. All right, so each day we're gonna have, they're called quick notes. Sometimes I'll call them important ideas. This is just taking everything we did in the activity and making explicit notes out of it. So we've got 3 things, or I guess really 4 things to talk about here. And these are your notes. So as I talk through, you can copy these down. I guess I'm going to skip the frequency table and we'll just talk about our bar chart and the circle graph first. So on the bar chart, remember a title. Remember to label your axes. Those are the lines that go up and down, side to side. And then make sure that your scale starts at 0. That's something that I skipped over. So like on last semester's bar chart, we had 0 at that bottom corner, and then we went up to like our maximum bar. Pareto chart, that is just organizing our bars from tallest to shortest. So not least to greatest as we did initially. Goes from the tallest bar down to the shortest bar. Bar chart's pretty easy. Hardest thing, everyone's going to lose points on it, is to label your axes. Make sure you remember your labels. Do not leave them out. It is free points on the test. You do not want to find yourself on the test or on the exam losing points for missing labels. Circle graph, or the pie chart. One important factor that we didn't mention is that those add up to 100%. So each of the wedges is going to add up to 100. The wedges need to have labels. So whether maybe you color each of them and you say, okay, over here red means TikTok and green means Instagram or something like that. Or you could just label inside the wedges as we did when we did this semester's data. The wedges themselves need labels. That's what we just talked about. And then the use case for a circle graph. Another thing we didn't really mention. We use a circle graph when respondents can only select one answer. So that means I can't ask a question that's like, okay, raise your hand for each type of movie you're okay with. And then I list like a bunch of different movies. We've got people raising their hand for multiple movies because they like different movies. That doesn't work with a pie chart because eventually we're going to find that more people voted than people that we have in total. And so those percentages would actually be more than 100%. So we're only going to use the circle graph when you are able to select one answer. What is your favorite social media? The word favorite there implies that you can only pick one option. Other questions, what's your favorite restaurant, right? Has that favorite word in there. What type of shoes are you wearing? You could probably only be wearing one type of shoes, hopefully. So keep that in mind. There are going to be some homework questions about that when we use a circle graph versus a pie chart. All right, finally, the example is going to be about this time series graph. Time series graph, we've got a numerical variable against a time variable. That time variable is going to be on the x-axis, which goes from left to right, and then the numerical variable is going to be on the y-axis that goes up and down. And we're going to connect those dots by time. So I'm actually going to show you how that works. Let's go ahead and clear it. So on this example, we've got different weeks and we've got distance that someone walked. For each of these, a week, that is our unit of time. So this is going to be the x-axis. And then distance, that is the numerical measure. Remember, we have that numerical variable on the y-axis. So all of these points are different points we have to graph. So like this would be 1, 2.1. So it's going to act just like it did in algebra class. Go over to 1, go up to 2.1, put a dot there. Go over to 2, 2.1 again, 3 and 2.3, 4, 2.3, 5 and 2.2, 6 and 2.4, 7, 2.5, 8 and 2.6, 9 and 2.4, 10 and 2.7. So once you have all your dots graphed, you're going to connect them from left to right across the time axis. So as I go from left to right on the time axis, just connect those dots up, connect them in order. So that time series graph shows us the trend of what happens as time goes on. So as we can see from that graph, we do have a pattern. As the weeks go on, this person, whoever's doing the walking here, is able to walk greater and greater distances, presumably. They started off at 2.1, they ended up at 2.7. So they've got a trend there. The difficulty of a time series graph, I provided you with a scale on this one. Sometimes you're going to have to make your own scales. So I had the computer do this for us, but if I was just looking at the data, I'd see, okay, my least on my numerical, we've got 2.1 miles. That goes up to 2.7 miles. So I would probably just go by my 2.1s, like go by 0.1s. Start at 2.1, then go to 2.2, 2.3, 2.4, all the way up to 2.7. And then do your graph that way and scale it and make all your points. The other important thing, and this is going to be true for dot plots, which we're actually not going to learn until next unit, but when we have numerical data, it is actually less important that we start at 0. So we do not need to start at 0. We're just going to have a kind of a break in the graph, and we're going to start at 2.1 for the distance. And then week as well. It doesn't necessarily need to start at the 0th week. This one started at the 1st week, but we could theoretically have, like, if you start in the 40th week of the year, we could start at 40 here. So when we have numerical graphs like this, it is not as important to start at 0 as it is for the bar graph. We're going to see what happens with the bar graphs on Monday when we don't start at 0. All right. So that is your classwork for the day. Classwork's going to be due today at 11:59, as I mentioned. Homework will just be due when it would normally be due. So that's going to be Monday at 8 a.m. Make sure to submit that on Canvas. Otherwise, have a great day and enjoy your time off school with your E-Day here. Goodbye.